Nitrogen, as an inert gas, is commonly used as an auxiliary gas in laser cutting. Generally speaking, it has the following characteristics and application scenarios. 1. Preventing oxidation reactions. Nitrogen can prevent metal from being oxidized, ensuring clean, discoloration-free or rust-free cutting edges, which helps maintain the quality and characteristics of the metal. 2. Blowing away melted materials. The nitrogen gas flow can blow away the melted materials generated during the cutting process, keeping the cutting area clean. 3. Improving cutting quality. High-purity nitrogen can create a stable cutting environment, providing consistent and uniform cuts. This benefits high-precision cutting applications by reducing errors and defects during the cutting process. 4. Protecting optical elements of lasers. The nitrogen gas flow can remove particulate matter from the beam path, reducing laser distortion. At the same time, it also protects the optical elements of lasers, reducing maintenance costs and downtime. Nitrogen is very suitable for cutting materials such as stainless steel and aluminum, as well as situations requiring high cutting quality. From the perspective of nitrogen supply methods, there are currently 3 main types. 1. Using nitrogen cylinders. Advantages: simple operation, relatively low initial investment. Disadvantages: requires regular replacement of nitrogen cylinders, which may affect production efficiency for factories with large-scale production or continuous long-term operations. Moreover, the transportation and storage of nitrogen cylinders pose certain safety hazards. Management also requires considerable manpower and material resources. 2. On-site nitrogen generation systems. For example, PSA nitrogen generators utilizes pressure swing adsorption technology to physically separate nitrogen from air. PSA nitrogen generators can continuously produce high-purity nitrogen to meet the needs of the laser cutting process. Advantages: can provide a continuous and stable supply of nitrogen, avoiding production interruptions due to the replacement of nitrogen cylinders, can adjust the flow rate and purity of nitrogen according to actual needs. In the long run, the cost of using nitrogen will be lower. Disadvantages: requires an initial investment, needs a certain amount of installation space, and ongoing equipment maintenance. 3. Cryogenic air separation for nitrogen production. Suitable for scenarios with very high nitrogen demand. Liquid nitrogen can be stored at lower temperatures and has a higher storage density. Advantages: large storage capacity, able to meet the needs of long-term, large volume gas usage. The cost per unit volume of nitrogen use is lower. Disadvantages: requires comprehensive safety protection measures, very high initial investment, and both equipment use and maintenance require professional personnel. In summary, each method has its own characteristics, and the final choice should be made based on specific production needs, equipment conditions, budget constraints, etc.